This is 5.8, part 2. We're continuing the problem where we're trying to solve for a, b, and c to find the equation of this quadratic. So step 3, use elimination method now again from the results from step 1 and 2. And we're going to just use eliminating the b. So to eliminate the b, if I add them together right now, I would get 5b. Neither one of those eliminated. So I'm going to multiply this equation by negative 2. I'm going to multiply this equation by 3. So that I'll get a positive 6b and a negative 6b. So I'll distribute negative 2 through to that top equation. So I get negative 30a minus 6b equals negative 42. Now I'll distribute the 3 to all the terms in the second equation. So 3 times 8a is 24a, 3 times 2b is 6b, and then 3 times 10 is 30. Now I add the equations together. You always add an elimination method. Negative 30a plus 24a is negative 6a. Then negative 6b plus 6b cancels out. And then negative 42 plus 30 is negative 12. What happens is now I'm down to a single variable, a. So I can continue solving this equation for a. So I would divide both sides by negative 6. And I get a to be 2. I've now found one of my variables in my system. Step 4 is to substitute that a value into one of the equations from step 1 and 2. So I'm going to just choose one of these two black equations. So if I look back on my slides, here was step 1, when we eliminated the c, and then here is step 2, where we eliminated the c. We're going to just choose one of these two equations that are circled here in the green and substitute 2 in for a. So I'm going to just choose this equation, and I'm going to substitute 2 in for a. So 8 times 2 plus 2b equals 10. 8 times 2 is 16 plus 2b equals 10. Then I'll subtract 16 from both sides. 2b equals negative 6. And then divide by 2. So b equals negative 3. If I chose the second equation, I would also get negative 3. But I don't need to do that. It's just showing it the work. So now I have a equaling 2 and b equaling negative 3. Step 5 is to now substitute a equaling 2 and b equaling negative 3 into one of the original equations in the system. I just chose the top equation from the system because it had the easiest substituting. So I'm going to substitute 2 in for a, negative 3 in for b, and now I just solve this equation for my last variable, c. So 2 minus 3 is negative 1. Then we're going to add 1. And then C equals -4. All right, last step is to take the A, B, and C values that you found in your system and substitute it into the function. So my A value was 2, my B value was -3, and my C value was -4. So now my quadratic function, remember this was a parabola, is 2x squared minus 3x minus 4. We could go out and graph that parabola if we wanted to and show that those 3 ordered pairs would fall on that quadratic function, that parabola. If you wanted to do this last step, you don't have to, is if you wanted to check to see if those 3 ordered pairs, these were your 3 original ordered pairs, if you would substitute them into the system, all of them would be true. I'm not asking that you do that, unless you wanted to. So there is your assignment for 5.8.